Hey, hello everyone. Welcome to Sigmoid Tech Talks. Today we are going to discuss on a topic on vectorization in natural language processing. I am Akshay Matam, working as a lead data scientist. So today I am going to present out the same topic to you. So what we are going to cover in this session is we are going to cover on vectorization and its needs, language models, and frequency-based vectorization methods. Also, we are going to cover about to it, which is a neural networks-based vectorization method. So going ahead, so what is vectorization and why is it needed? This is something which we need to know. As we know that machine learning algorithms takes input in the format of numbers, how are we going to represent text to the machine learning algorithms? So the process of conversion of text into numbers is something, or this process is known as vectorization. How well we represent text in the format of numbers, or that it exists in various ways. So we need to have a similarity existing between the words, or we can find semantic similarities between the words. If you take an example of this where male to female is present, man and woman are similar in the vector space, there should be a similar semantic similarity that needs to be observed while we represent it in the format of numbers. Similarly for king and queen, we can, if we go to the tenses, the same approach will happen where we need to represent two keywords in the vector space similar to each other if they are in different tense. Same applies for the country and capital as well. So there are various ways where we can represent a keyword in the format of keyword in the format of numbers. So a naive approach would be just giving all the text or text into a hashing, converting text into a hashing method where each keyword will be assigned a number, and we'll just represent a sentence in the format of numbers. So if you observe here, like Sachin is considered god of cricket, we have taken three documents and created a vocabulary out of it, similar to dictionary, and assigned each keyword a number and represented the sentence in the format of numbers. Sachin by 1 and is by 12, considered by 5. So similarly, we have represented for all the documents. What are the drawbacks if we represent it in this plain way? So as I mentioned, like there isn't a semantic similarity that has been observed between the words. If it is a verb form or if it is in any other form related to each other, it is unable to capture the information. Also, it is unable to capture the context of the keyword. So if we represent apple as a keyword, it is not same in both the contexts where it is represented as a fruit or as a technology. So going forward, how can we create it? So we have come across language modeling techniques. What are language models? Language models are nothing but models which analyze the patterns, which capture the semantic similarity or the contextual similarity in the words for prediction of the keywords. In that way, we train the model to predict the keywords to observe the features and the characteristics of that language. These language models are used for the vector generation. So what are the types of models, or like how many types are there? There are broadly two types of language models which we can observe. One is on the statistical models and the other is neural networks models. Statistical models are those which have been developed based on the classical probability or statistical approaches. So giving an example, count vectorizer, TF-IDF, n-grams, these are all the few examples which we are going to discuss later in the same video. And also coming to the neural networks models, these are the state of the art techniques where once the evolution of neural networks comes, these models got implemented. So these can capture the information better and also represent the keyword in a much more appropriate way. Examples of neural networks models are word to vec, BERT, etc. So going forward, how are we going to create language models? What are all the use cases that we can take? There are many use cases that we can take to implement the language modelings. Few of them are next sentence prediction, where you can observe in our daily use cases, where we'll be getting a suggestions based on the next word while typing in the keypad. So this is one of the use case. And also mask language modeling, similar to the blanks that we are seeing, like the model is trained to predict the keyword which is masked while training. So similarly, translation one language to other language, named entity recognition, one more use case, question answering systems, multiple use cases can be observed while creation of language models. In this session, we are going to cover on statistical modeling techniques, which are frequency-based vectorization, in which we are going to cover count vectorization and TF-IDF. So, coming to frequency-based vectorization technique, we are going to represent each sentence in the form of frequency of distribution of the keywords. So in the count vectorizer, we are considering a vocabulary generated based on the list of documents or the corpus of documents in which we have, and we are going to create a vocabulary out of it. And each sentence we are going to represent based on the frequency of the keywords that are present in that sentence or the document. So consider these as an example where in document one, out of these three documents, we have created a vocabulary, and then each document one is represented based on the keywords that are present in the sentence. So consider Sachin is considered god of cricket. All these keywords are marked as one, as these are repeated once in the document. If they are repeated twice or multiple times, we are going to represent with the number that have been the frequency number that the keywords have been repeated. So in this way, we are going to establish a relation between the documents based on the keywords present in the document. What are all the drawbacks that if we represent the documents in this form? Count vectorizer, in the form of count vectorizer, we are unable to identify the more important or less important keywords in the sentence. Also, we are unable to capture the information of the semantic similarity or the relationship between the keywords. And if we have a larger length of the document vocabulary, the length of the vector is going to be huge, and processing needs higher hardware to process. So the contextual information capturing will also become less if we have a huge length of vocabulary. How can we overcome few of these drawbacks? So we have created one more form of representation, which is TF-IDF, in which we are going to have term frequency and inverse document frequency as two terms. The TF term will provide information on importance of the keywords. That is, higher frequent keywords in a sentence will be given higher importance, and the terms or the words which are repeated across the sentences or the documents will be given a less importance. Why it is happening? So if we see the keywords like is, was, or any of the stop words or conjunctions, those needs to be given a lesser importance when it comes to the importance of the keyword, right? So that is where those keywords are repeated across the documents, and with the help of IDF term, we are going to reduce the importance of the keyword or reduce the scores of those keywords. And TF term will increase the scores of those keywords which are higher in number across in a single document. So rare words are represented with higher value, and the frequent words which are repeated across the documents will be represented with lower value. If we take the same example, here we can see that is the keyword which is repeated across the documents, and it has been given lesser score when compared to the keywords like Kohli or Sachin. And if we see the considered keyword which is moderately distributed across the documents, it is given a moderate score. What are the drawbacks when it comes to TF-IDF approach? Even though it captures the information on the importance of the keywords, but it is unable to capture the information on semantic similarity or the semantic meaning of the keyword. Still, it is unable to figure out whether apple as a keyword is in the context of fruit or is in the context of gadgets or technology. So this is on TF-IDF. In this session, we are going to cover on word-to-vector, which is a neural networks based embedding technique or vectorization technique. So coming to word-to-vec, This is a neural network based architecture in which we are going to create embeddings or vectors for each keyword based on the contextual capturing of the information. So looking at the architecture, we have input layer here and we have initiated embeddings randomly with the numbers for each keyword based on the hyperparameter length which we are going to give. And we'll have a one hidden layer over here and we'll have a output layer which is the length of vocabulary which we have. So this is how we have the architecture of word-to-vec. We have two types of processes in which we can train this model. One is based on continuous bag of words technique, which you are going to see now, and then there is skip gram technique, which you are going to see in the next slides. So coming to continuous bag of words, how we are going to capture the input or training data is we are going to have a sliding window technique here in which the model is asked to predict the target keyword and giving the context as an input. So considering the window length as 3 here, by considering the same example as in the previous session, so Sachin is considered god of cricket and window length as 3. Initially in the step 1, we can see that Sachin and is are given as an input and model is asked to predict output keyword as considered. In the step 2, we are going to give is considered god as the moving the sliding window to these keywords, creating is and considered as an input and model is asked to predict the keyword god. So after covering all the whole sentence length, we can see that input or training data has been created. So while training the model, we'll pass this inputs to the input layer and outputs are being predicted by the model. While learning on how to predict the output keyword, the embeddings which are initiated randomly will get updated based on the backpropagation technique in the neural networks. This is how we are going to update the embeddings for each of the keywords. Moving on to skipgram technique, this is similar to continuous bag of words, but just an reverse of the architecture. We are going to give keyword and model is asked to predict the context around the keyword. So taking the same example, we have the window size of 5 here, sliding window size of 5 here, taking considered as the input keyword, the model is asked to predict context around it. So as we have taken 5 as the window length, we have four keywords around the keyword considered here. Similarly, in the next step, we are going to consider God as a keyword and it is going to cover context of 4 keywords, which is considered of and cricket. So this is passed as an training data to the architecture, and in the similar fashion that has happened in the continuous bag of words, lookup embeddings are updated based on the backpropagation technique. So when did continuous bag of words works and when did skip gram works? Continuous bag of words work appropriately or better in which we need to concentrate more on the more frequent keywords, or we need to represent more frequent keywords in a better way. Whereas skipgram works better with a small amount of data and is found to represent better if we have rare keywords that are present in the data. So like this, how can we see that there is a information or contextual information that is being captured in the keywords? Considering these examples, king, man and woman, we can see how the vector is being represented by these word-to-vec models. If we see here, king, man and woman are similar in nature when it comes to human entities, right? So that is where we have a similarity present in the vectorization. And also man and woman are very similar to each other, and also it can differentiate between king and has gender equality or gender similarity which is present in this sentence. So this is how we are able to capture the contextual information in the data with the representation of word. So yeah, thank you. This is on word-to-vec. We'll see in the next sessions with the different embedding techniques. Thank you.